What if I told you that for 30 years, we've been staring at the most important map in human history, the blueprint of our universe, and we've been reading it upside down? We like to think that science is this linear climb, an endless staircase where every rung is solid and certain. But what happens when you discover the ground beneath your feet isn't rock? What if it's just paint on a wall? Today, we are going to peel back that paint. We're starting by looking at the ghost of modern physics, dark energy, the mysterious force that supposedly makes up about 2/3 of everything in existence. Then, we'll dive into the radical new research coming out of Oxford University that suggests this ghost might not exist at all. Finally, we'll explore what it actually means for our understanding of reality if we had to delete 1/3 of physics from the textbooks overnight. Let's set the scene. In 1998, astronomers were looking at something called Tug-of-War supernovae, essentially standard candles. Because these explosions always happen with roughly the same brightness, they act like cosmic lighthouses. By measuring how dim they look from Earth, we can figure out exactly how far away they are. And when they looked at these candles, something weird happened. The farther away the supernovae were, the faster they seemed to be moving away from us. It wasn't just expansion, it was accelerating expansion. It was as if someone had thrown a pebble into a pond, and instead of the ripples slowing down, they were suddenly picking up speed across the surface. To explain this push, scientists did something very human. They invented a placeholder. They called it dark energy. It's the ultimate cosmic I don't know. We can't see it, we can't touch it, and we have no idea what it is. But our math insisted that something had to be there to provide that shove. For 3 decades, dark energy has been the cornerstone of the standard model of cosmology. It's the reason we believe the universe will eventually fly apart into a cold, lonely void, the Big Freeze. But now, a team led by Xavier Sarkar at Oxford is suggesting that this entire narrative might be built on a very clever, but fundamentally flawed, interpretation of data. They aren't saying the supernovae don't exist, they're saying we've been misreading them for 30 years. Think about that for a second. Imagine you see a car moving away from you, and it looks like it's speeding up. You assume the driver is hitting the gas. But what if your speedometer was just calibrated wrong by someone 30 years ago? Sarkar's team argues that when you strip away our preconceived notions of acceleration, the data doesn't actually show a push. They suggest we are falling into a trap called confirmation bias, the tendency to see what we expect to see because it makes the math easier to handle, potentially ignoring how different observations might be influenced by local physics or specific data selection. The standard model is incredibly comfortable. It's prestigious. It has billions of dollars of funding tied to its existence. Admitting that dark energy might be a mathematical hallucination feels like admitting we've been chasing ghosts in the attic for 30 years because we were too afraid to admit we lost our keys. If Sarkar is right, expansion isn't accelerating at all. It might be steady, or it might follow something called the timescale model, a radical idea that suggests our perception of cosmic time and space is biased by where we are looking from and how different observers perceive these shifts in data. It's like trying to describe a forest while standing inside one tree. You think you see the whole woods, but your perspective is limited by your own position. The Oxford team suggests that our standard candles are being interpreted through lenses of bias we haven't fully accounted for. This creates a fascinating, almost cinematic conflict. On one side, you have the institutional weight of decades of consensus the standard model. On the other, you have an underdog team pointing at the same raw numbers and saying, wait, look closer. The push isn't there. Now I want to pause here for a second because this is where it gets messy. In science, disproving something isn't as simple as flipping a switch. There are already skeptics pushing back against the Oxford paper, arguing that while their math is interesting, there's still other evidence like the cosmic microwave background radiation that seems to support acceleration. So we're left with this high-stakes tug-of-war between 2 different ways of reading the same map. It's not necessary that one side is wrong and the other is right. It's possible that our current tools are simply too blunt to see the truth clearly yet. This brings us back to why this matters to you, not just as someone who likes space facts, but as someone who thinks about how humans understand reality. We have a tendency to create entities to explain our ignorance. When we don't understand the wind, we call it the breath of gods. When we didn't understand the expansion of the universe, we called it dark energy. Is dark energy a real physical thing? Or is it just a very sophisticated way of saying we don't know yet? If the Oxford team wins this argument and dark energy vanishes from our equations, we have to rewrite nearly 2/3 of what we think we know about the fate of everything. The stakes are existential. If expansion is accelerating, we end in the Big Freeze, where every atom eventually becomes so far apart that even light can't travel between them. But if it's not, well, the ultimate fate of our universe might be something much more complex, and perhaps much less lonely. We're living in a weird moment in history, where the settled truths of yesterday are being interrogated by the very tools we used to build them. It's uncomfortable and it feels like chaos, but that's exactly what science is supposed to look like when it works correctly. It should feel like you're constantly on the verge of realizing something huge was a mistake. The fact that we can even have this conversation, that we can question our own fundamental models and argue about what is real, is perhaps the most human thing about us. We aren't just observers of the universe. We are its self-aware witnesses, constantly trying to fix the lens through which we see it. So, next time you look up at the night sky and think about those vast distances, ask yourself what else might be a ghost. What other forces have we invented because our maps weren't big enough to show us the truth? Maybe dark energy isn't out there pushing things apart. Maybe it's just here, inside our own heads, a placeholder for the next great discovery we haven't made yet.